Okay guys, we're going to start with today's lesson. We want to be able to find the surface area of pyramids. The two vocabulary words are first, a net. A net is a pattern that you fold to form a three-dimensional figure. And then also the surface area, which is the sum of the areas of a three-dimensional figure. Here's an example of a net of a square pyramid. Notice that the base is a square, hence the name square pyramid. We name pyramids by the shape of their base. Notice the faces, the lateral faces, are all triangles. So we have a square base, but each one of the faces is going to be in the shape of a triangle. The triangles all come to one point called a vertex. Here's an example of how we would find the surface area of a square pyramid. First, we find the area of the square base. The area of the square base would be the bottom, and that's 7 times 7, and that gives us 49. Then we have four sides. All right, and notice that all four sides are the same. So we need the base of the triangle because the side is a triangle, and we need the height of the triangle. The base is going to be 7 because it's a square. These are all 7s. So the base is 7 and the height is 10. So we need 1/2 of 7 times 10. And that's what we see here, 1/2 of 7 times 10 to find the area of one side. But there are four sides. There's one side, two sides, three sides, four sides. So we have to find the 1/2 of 7 times 10. We have to do that 4 times. We add together all four triangular sides plus the square base, and that's where we get the surface area of 189, and that's what we see here. And the units, of course, are going to be square units. All right, so let's take a look at our first example. All right, let's go here. We want to be able to find the surface area of this square pyramid. All right, so let's start with first the base. The base is a square because we're told that these are square pyramids. So the base is a square. So if I find the area of the square, I'm going to do area is equal to the length of the side squared. So the area is going to be equal to 2 times 2, and we get 4 square feet for the area of the square base. But then we have 4 triangles, and each of those triangles has a base of 2 and a height of 3. So we have the area of the triangle is going to be equal to 1/2 of the base is 2, the height is 3, height's going to be 3. So 3 times 2 is 6. 1/2 of 6 is equal to 3. But there are 4 of those faces, right? 1, 2, 3, and 4. There are 4 triangular faces. So instead of doing that calculation 4 times, I'm just going to multiply that area by 4. And that 12 square feet is going to give me the area of all of the triangular faces. So my surface area is going to be equal to the 4 square feet of the square base plus the 12 square feet of the triangular faces. 4 plus 12, my surface area is going to be equal to 16 square feet. All right, let's try our next one. Let's start with the area of the square base. So the area of the square base is going to be equal to 5 times 5. 5 times 5, which is 25 square centimeters. But then we have 4 triangular sides. So the area of one of those triangles is going to be 1/2 the base times the height. Well, the base we know is 5. The height, which is the perpendicular segment to that base, is also 5. So 1/2 of 5 times 5, well, 5 times 5 is 25. 1/2 of 25 is 12.5. If I multiply that by 4, 4 times 12.5, it's going to give me 50. So my surface area is going to be equal to the 25, which is the area of the base, plus the 50, which is the area of the 4 triangular faces, so the surface area is going to be equal to 75 square centimeters. All right? Our last example. The base is a square, and the square has a side length of 4. So the surface, let's do that again. So my area of the base is going to be equal to 4 squared, which is 4 times 4, right? And that's going to be 16 square inches. And then the area of one of my triangles is going to be equal to 1/2 base times height. All right, 1/2 base times height, and my base is going to be equal to 4. And the height of the triangle, we're told, is 3.6. Well, what's 1/2 of 4 is 2. 2 times 3.6 is going to be 7.2. That's 7.2. Right, that didn't come out too well. Let's do that again. All right, we get 7.2. 7.2, and those are square inches. Now that's the area of one triangle. We have to multiply that by 4 because there's 4 triangular faces. So when we multiply that by 4, 7.2 times 4, 4 times 2 is 8, and 4 times 7 is 28. So we have 28 plus the 16. 28 plus the 16, that's going to be what? Let's see, is that 44? That is 44.8. All right, that's 44.8, and those are, let's see, square inches. 44.8, those are square inches. All right, so that's going to be our surface area. Now those are 3 examples of finding the surface area of a pyramid when the base is a square. Right? It's a much easier calculation when the base is a square because all of the triangular faces, right, are all going to be the same. So we just have to find the area of one triangular face and multiply that by 4. All right. Let's see what happens if the base is not a square, because we also have triangular pyramids where the base is the triangle. This is what the net of a triangular pyramid would look like. You have your base as a triangle, and instead of 4 triangular sides, we're going to have 3 triangular sides. So the net's going to look a little bit different based on the base of the pyramid. All right, here's an example problem where we have the base is a triangle. Looks like it's an equilateral triangle, so all the sides are 6. The height of the triangle is going to be 5.2 feet. That's the height of the triangular base. Then we have the height of a triangular face, which is going to be 8. So we have to find the area of the triangle, which is going to be 1/2 of 6 times 5.2, and that's what we see here, 1/2 base times height. But then I have 3 triangles where I have a base of 6 and a height of 8. So that'd be 1/2 of 6 times 8. All right. I add the 24 plus 24 plus 24, which is 72, plus the 15.6, and that's where we get a surface area of 87.6. All right, and let's see what that's going to look like with our calculations here. Okay, first we find the area of the triangular base, and it looks like the triangle is going to be an equilateral triangle, so all of these sides look like they're going to be 2. Then we have the height of the triangular base, and we have the height of the triangular face. Okay, so let's start with the area of the base. Area is going to be equal to 1/2 the base times the height. Base is 2, height is 1.7. So it's 2 times 1.7. Right, and we multiply 1/2 of 2 is 1. 1 times 1.7, so we get 1.7 square centimeters, and that's just the area of the triangular base. Then we need to find the area of the triangular faces, and there's 3 of them. All right, So let's start with that. The area is going to be equal to 1/2 base times height, but the base of the triangular face is 2, the height of the triangular face is 3. It's 1/2 of 2 times 3. 1/2 of 2 is 1, 1 times 3. We get an area of 3 square centimeters. But there are 3 triangular faces. So I'm going to multiply that value by 3, and I get a total surface area of 9 square centimeters for your triangular faces. But we still have to add the area of the triangular base, which is 1.7, and we wind up with 10.7 square centimeters for the surface area. All right, so just to review, we find the area of the triangular base using 1/2 base times height, and then we find the area of the triangular face using 1/2 base times height. All 3 of these triangular faces are the same because we have an equilateral triangle, so I just have to find the area once, multiply that by 3, and I get what's called my lateral area, which is the area of the triangular faces. All right, let's take a look at the next example. We start with the area of the triangular base. It looks like it's an equilateral triangle. All of the sides are the same. So I start with my area, which is going to be equal to 1/2 the base times height. Your base is 9. Your height here is 7.8. All right, and then you multiply 1/2 times 9 times the 7.8. So we have 4.5 times 4.5 times 7.8, and we wind up with, this is 1/2 of 9, which is 4.5. 4.5 times 7.8. I'm going to do that on the side of my paper here. 4.5 times 7.8. We wind up with 35.1. And 35.1, those are square inches. That's just the area of the triangular base. Then we need the area of the faces. So the area is going to be equal to 1/2. The base is 9, but the height of the face is only 7. So we need 1/2 of 9 times 7. All right, so we need 1/2 of 63. That's going to be equal to 31.5. 31.5. But there are 3 triangles that have that area of 31.5. So if you multiply 31.5 times 3, you wind up with 94.5. We take the area of the 3 lateral faces, which are triangles. We add the area of the base, which is 35.1, and we wind up with 6. That's 9 decimal point. 9 and 3 are 12. So the surface area is going to be equal to 129.6, and those are square inches. All right. Last example. Once again, we have another triangle, so I start by finding the area of the triangular base. Area is going to be equal to 1/2 base times height. My base of the triangular base is 20. The height here is going to be 17.3. So that's 20 times 17.3. All right, and we multiply that. And divide by 2, and wind up with 173. Those are square yards. That's just the area of the base. Then I want to find the area of the lateral faces. Same formula because they're triangles, 1/2 base times height, but my base here is 20, right? So the base doesn't change, but the height of the face is 12. All right, so 1/2 of 20 is 10. 10 times 12 should be 120, but there are 3 of those faces, so I have to multiply that by 3. That's going to give me what, 360, plus we have to add the 173, and when we do that we wind up with, let's see, 3 6 and 7 is 13. 3 carry the 1. That's 533. And those are square yards for the surface area. Alright, so those are 6 examples of finding the surface area. 3 of the examples, you have the square prism. The base is a square, so it's a little different calculation for the base. And then there are 4 lateral surfaces if the base is a square. If we have a triangular base, there are only 3 lateral faces that you're finding the area of. Alright, I hope that was helpful, and see you next time.